Hey guys, John Catalano here from Diamond Audio. In today's workshop, we're going to be talking about system tuning and the tools that are required to do that properly. The list isn't long, but these are very critical. You have to have these tools. You have to have a multimeter. You have to have some sort of oscilloscope, either a handheld portable one or a DMRTA for audio controls, another great tool. But you need some way to be able to see the signal and see if it's clipping. So those two things are mandatory. I'm going to ruffle some feathers with this one, but DSP is mandatory. And let me tell you why it's mandatory. We have a very limited power supply on a bike. We need to maximize everything we're doing on that bike so we utilize every piece of or a little bit of power without overdriving things, without wasting power on frequencies that we're not going to be able to hear, or running things through passive crossover networks. We can do everything we need to do to maximize that through a DSP. We can do time alignment. There's so many other things, and I'd love to go in depth and teach you about all these things. So let's just start with time alignment. Why do I need time alignment on a bike? We're not trying to get a sound stage like we would be doing in a car. We're trying to maximize drivers so we're not overdriving them to compensate for cancellations we may have. The best example is a bike that has lowers and bags. If you have a set of lowers on a bike and then you also have a bag set up, those distances are so out of whack that there's usually a big mid-bass hole right where the rider would be. We can fix that by just adding some time alignment, or time delay is the true term, and we can maximize that so the sound is reaching the rider at the exact same time and we don't get those cancellations. So doing that allows us to not have to overdrive either the front drivers or the rear drivers to compensate for that cancellation. So we're maximizing efficiency. The other reason we want to use that DSP is for crossovers. If we're going through a passive crossover, that is utilizing some of the frequencies that are being driven and they're eaten up by the crossover, right? So they're going to somewhere, they're getting turned into heat. If we use an active crossover instead of a passive crossover, like in a DSP, we're only amplifying the frequencies that we need. So we maximize the power going to that driver, whatever it may be, run more efficiently. It's going to be better sounding because that's a exact frequency we're going to cross it over at. And then we have adjustability. We can do 6, 12, 18, 24 dB. So we can really fine tune that so it's doing exactly what we want it to do. Speaker specs make a big difference. So a lot of guys, they're just going to look at the size of the driver and they're just going to pull a random frequency out of their head. They're going to be like, oh, it's a 6x9. I'm going to cross that over at 80 hertz, or I'm going to cross that over at 60 hertz, or whatever the case may be, without really just looking at the spec sheet. What's the FS of that driver? Especially with some of our drivers where we have mid-ranges and we have mid-range drivers that look identical, but they're designed to play at different frequencies. So you want to look at the FS of that driver and you're going to adjust your crossover point accordingly so you're not having issues with that driver playing a frequency that's maybe too low, which does two things. It's not good for the driver and it's a waste of power. And again, we're talking about efficiency again. We want to maximize everything on that bike and we want to get the most sound out of those drivers. So if we're playing the frequencies that driver's designed to play, we're going to get the most out of that. We're going to get the most power handling out of that driver, and we're not going to have issues with distortion and speaker failures and all these other things that could come up when we're not looking at the specs. All right, now let's circle back to the fact that there is limited power on a bike. We've already kind of touched on it here and there, but let's just go in depth a little bit more. If we're lucky, we have 40 amps of current on a bike. They're stator driven. We've got a small battery for reserve. We're really limited on what we can do on these bikes. So again, we need to maximize the efficiency of everything that we're doing. We don't want to waste power in the head unit. We don't want to waste power on the amplifiers. We don't want to have stuff going through passive crossovers. We can utilize these things to maximize the amount of current draw from that system and make sure we're utilizing it to the most of its ability. So, keeping power wire runs as short as possible, crossing over those speakers in the right frequencies, like I said earlier. These things are going to help keep you running for a long time, keeping issues with the bike not having a dead battery, or the customer riding somewhere and the amps are cutting in and out, or something of that nature. which just kills the customer experience. We don't want any of those things to happen. And you also take a risk of having failures of your equipment when you're running at low voltages. So we want to take into consideration how many amplifiers we're putting on that bike, how much power we're drawing from that system. Is that customer taking the bike home and charging it? Do we have a tender or an outboard charger? All these things need to be taken into consideration when designing the bike and talking with the customer, making sure they understand that, hey, you have a limited current in this bike. You're going to have to charge this bike when you get home, or whatever the case may be, to make sure everything is running at its optimum performance and they get the best listening experience possible. All right, and battery performance is critical. So as we touched about, you have limited power to start with. We also have a battery that is also limited in size and scope. You know, they're small on the battery, or the small they have to fit under a seat and things of that. So first off, when you get the bike in, you want to test it. Harley guys are just famous for not charging their bikes, letting the battery drain, and just killing it over and over again. And as long as they get the bike to start, they think it's fine, but it's not fine, right? We're working with a limited power supply. So we want to make sure that that battery is in good condition. So I would put it on a tester, see what voltage we're at, ask some questions. What's the age of the battery? And if there's any question that that battery is not in good condition, before you do anything else, you need to go ahead and get that thing swapped out. And you can also qualify the customer then, because if they're putting a big system in there, maybe you need to add a lithium battery or a better AGM battery or something of that nature to make sure when you put in your equipment, it's going to perform at its best and the customer is going to be happy. You're not having to bring the bike back in and spend time that you don't no money on doing maintenance, when that could have been prevented in the beginning by just doing a simple test. All right, guys, thanks for joining me on this workshop. I hope some of these tips and tricks help you either install better or have a better experience for yourself, your shop, and your customers, so you can do better motorcycle audio and make more money, because that's what we're all here for in the end. So if you have any other questions, feel free to reach out to me directly or visit us on diamondaudio.com. And until next time, keep it awesome.